Hello everyone. So we are going to start today's simplification of CFG. Now we know that CFG is context-free grammar, and in context-free grammar, each production can derive to any number of terminal or non-terminal symbols that we already know. Now, why we need to simplify CFG? That's the first question comes in our mind. So why there is a need of simplification? The first thing is efficient parsing, as we know that CFG is used in compilers as well. So the parsing will have fewer computations that will make it more efficient. That's why it's important to simplify CFG. Second is better understanding. If there are less production rules in grammar, then it will become better to understand, right? So that is second point. Optimization. The number of computational will be less and computational efficiency will be higher in compilers and also in language parsing. That's why simplifying a CFG is important. So now we know that why simplifying is important. Now how to simplify it. So there are three different things that we need to do in simplification of CFG. First is a removal of useless symbol. Second is elimination of epsilon production or null productions. Third is removal of unit productions. Now we'll see each of them one by one. When we complete all three steps, then only we can say a CFG is simplified. So let's go to the first type, which is removal of useless symbols. Now, what is actually a useless what is actually useless symbols? Useless symbols as in if in a production rule, a, a production is there which is not used in the right hand side. If you see in this example, there are four rules given, and in the four rules, if you see, this capital C is never used in the right hand side of any production tools. That means this is the start symbol, right? So from start symbol, there is no way to reach this production. So it's a useless production in the grammar, right? So we can directly eliminate that or remove it. That is useless symbol, and that is how removal of useless symbol happens. Also, second is if you see this production rule, in this production rule, A is deriving to small a and capital A, right? So it's like if I have a production goes to A, small a and capital A. Here, if I try to use this production, so the first will be A will be replaced with small a, capital A, right? That will be the first thing. Next, this will be replaced with, um, sorry, this will be replaced with A. So this was the replacement. Next will be this. In this way, if you see, we are trying to simplify it every time by adding this production rule in each time. So whenever we write the production rule here, it's not simplifying it. It's just recursively going to the same rule again. So there is no end of this, right? So if this production is not used to derive a terminal symbol at the end, there is no use of this production, right? So that's why this is also a useless production rule. So we can directly remove this production rule from the grammar. So the simplified version of this will be have only the first rule and the third rule, right? So this rule will be eliminated and the fourth rule will be eliminated. So this is the first type, removal of useless symbols. Now let's go to the second type. So second type is elimination of epsilon productions. Now, what is actually epsilon production? Epsilon production is a production which goes to a epsilon symbol, that is a null production, a null symbol, and because if your production is going to a null symbol, that means it's not adding any value to the derivation, right? So that's why we need to remove this epsilon production. So there are different steps. First step is to find all the nullable non-terminals. So if I take this particular example and try to find nullable um, symbols here. So the first nullable symbol I can see here is B, which directly goes to this B, capital B, and epsilon, right? So this epsilon is a direct epsilon symbol. So B is nullable symbol. So B is there. Second is we can see capital C is there. This capital C goes to C and also epsilon. And this epsilon is also a nullable symbol. So B, C, both are nullable symbols. Plus this A is also indirectly going to a null value, like because B and C is deriving to a absolute symbol, right? So A is also a nullable non-terminal. So after finding all the nullable non-terminals, what we need to do is we need to replace each production rule which uses this nullable symbols and create new productions with it. So the first production that I can use it, I can change this, let's say B. So if I replace B with um, using the nullable symbol, if I use this will be the original production that is done. If I use capital B's null production here, this will become small b, right? Now this only two production rules are there. That's why this is done. So B is done. Doesn't have any nulls production now. Now let's talk about C. Now C has this C and capital C two terminal and one non-terminal. If I use the null production here, this will become a small terminal because I have used null production in C, right? So this is done. So C is also done. Now, if I put the same in AB, so AB derives to B and C, right? So here, if I put null production of B, this will become capital C. If I put null production of C, this will become only B. If I put null production of both, it will have only absolute symbol. So we don't need to write it. So A is also done. So three rules are done. Now let's talk about start symbol because start symbol also uses these three null productions, right? So the original uh, production rule is A, B, capital C and small d. Now, if you see, if I put all the symbols here, still it will not become null because this small d will be there, right, at the end. That's why it's not a nullable symbol. Now, if I put the null productions of each nullable symbols, so the new productions will be, first will be if I put A as a uh, null symbol, this will become capital B, C and small d, right? If I put B as a null symbol, it will become capital A, capital C, D, right? Now, if I put null symbol C as a null symbol, it will become capital A, capital B, and D, right? Now, if I put A and B as a null symbol, the new production will be C, small d, right? If I put um, A and C as null symbol, this will become B, small d, right? If I put B, C as a null symbol, it will become capital A, small d, right? If I put three of them as a null symbol, it will become only D, right? So all these production rule will be there for A's production, right? So this will become now new productions of ours, and this whole example will not have any epsilon production or null production. So that's how we solve uh, elimination of epsilon production. Now, two things are done. Let's go to the third one, which is removing unit productions. Now, we know that what are unit production? Unit production are those which derives, I mean, a non-terminal derives a single non-terminal, right? You can see here, if a terminal is non-terminal is deriving a single non-terminal that called as a unit production. So in this example, if you see the first unit production is this S is deriving to this capital C, the first unit production. Second is this B is deriving to this capital A, which is again a unit production. So two unit productions are there. So first step is to eliminate unit production is to find the unit productions. Second is replace each unit production with its derivation. Let's say for here, if I see this production and there is a unit production which goes from S to C, I can directly put the derivation of C, which is here 0, 1 here. If I put this, this will become S 0, 1, 1B 0, 1, right? Directly putting the substituting the production rule, right? So that is simplified. Now for B, which goes to directly A, we can put this whole production rule here. So this will also become a simplified one. So for this example, after replacing two unit production, which is this C and A, the final answer will be this, where 0, 1 will be um, the production that we substituted here, and here this is production we have substituted here. So this is how we eliminate unit production. So these three things are done. First is removal of useless symbol. Second is elimination of absolute production. Third is removal of unit production. So after doing this, then we can call this CFG as simplified CFG, right? So I have some questions for you. Try to do it on your own. The first one is to removal of useless production. If you see any useless production, try to remove it. Second question here, this is for absolute productions, null production, and third is to unit production. So try to solve it on your own. And yeah, thank you.